Hey everyone, and welcome back. This here is a roll of PETG 3D printer filament. I am getting more ambitious in the stuff I want to design and build for the 3D printer, and so I've ordered some PETG so I can try this out. It's got a few things that I really like, one of which is resistance to chemicals and resistance to water and stuff like that. So I bought this filament to experiment with. However, my 3D printer was the cheapest printer I could buy at the time. So before I go into this, I need to do a couple upgrades. One of which is a parts cooler. So a parts cooler is fairly simple to implement. You just sort of hook up one of these fans onto the side of the extruder and have it blow with a little duct. This is not something that I designed, but this is something I found on Thingiverse. So you hook these two up together and you put that onto the side. That's pretty simple. The other thing though is my 3D printer has a extruder which is not reliable. Let me show you what I mean. This is the extruder from my 3D printer, and how it works is there's this one toothed gear right over here that grabs a hold of the filament and pushes it through this tube here towards the hot end. And there's this little guide bearing here, which all it does is it squeezes on the filament. You can see like that. The filament will go in between there and keeps this tight. Well, this only has one gear, this side, that can grip onto the filament. And I don't know if you can see, but there is full of powder everywhere inside here. And that powder is actually some of the filament stripping. Don't know if you can properly see that down in there. So my solution is to upgrade this extruder. Let me take this off the printer and bring it to the bench, and maybe I can explain it a little better. Back at the bench now, and this here is the filament path. It goes right in between these two gears. There's a spring, this one here, to push this idler gear up hard against this gear, and the harder that this is pushing, the less chance it's going to strip the filament. So this gear, the teeth literally bite into the filament to move it along this way. So it just passes through that little hole there that you maybe can or cannot see, and through this one, that hole there that you can or cannot see, not sure. And here is all the powder I was telling you about. This is all my gray PLA Plus filament. Now PLA Plus is a little bit harder than PLA. It's a little bit stiffer, so it has a little bit more trouble with this brass gear, but I expect that PETG might be something similar. So what's the solution to stripped filament? Well, a company called Big Tree Tech developed a BMG style extruder. This is not one of those. This is a copy. It's a clone of that, but it should work just the same. This one here has dual gears. So one gear here and one gear on this arm, and they mesh together, and when the case is supporting all this, what happens is the filament rides through this path here, this little serration in between there, and it's gripped on both sides. These are known for way better extrusion. On top of that, the filament path is quite well constrained. It comes through this hole here and pops through the very sharp edge that you see right here. You see the fact that that's a bit of a wedge shape in here? Don't know if you can see that right there and here. So the gears take up almost all the space in this cavity, and only a little bit of the filament is exposed. And so these BMGs are supposedly great for even flexible filaments. And if you have a E3D style hot end, you can actually run this direct drive. So the hot end could be right here. I don't, so I will be using this little adapter that came with it. Now this does mean you need a little bit of E-step compensation, the amount of steps your stepper motor will take, because this is not driven directly from the stepper motor like this. So there's the stepper motor and there's the gear. This one here requires a gear be installed, and it spins this gear, and this gear will come and spin these two. So this is something like a 3-to-1 ratio, so you can actually use a smaller stepper motor. Let me show you the stepper motor that comes with it, this one here, compared to the stepper motor that came with the printer, this one here. So you get more torque out of the same size motor, or you can have a smaller motor and not lose torque compared to stock. So let's go set this up in my terribly lit 3D printer area and see how the calibration process goes after. So the very first thing you need to do when you are setting up a new extruder is you need to change the E-steps. The E-steps are the amount of stepper motor steps per millimeter. So I'll just go do this right on the screen, and I can never remember where it is. I think it's control and then motion. E-steps per millimeters. So this one's set to 90, but we need 415 for this this particular extruder. This will take a while. While I'm in the menus too, I heated up the hot end because you need it in order to move the extruder. So those two things are going. I will bring you back when this is done and saved. Okay. That was an absolute nightmare. First and foremost, it took way too long to do on the screen here, so I hooked it up to pronter face, so there's actually a cable you can just barely see in the image down here. So it's been saved through pronter face, 415 millimeters. Also, or 415 steps per millimeter, I should say. Also, for some reason, the motor that came with it requires higher current. I guess it's a lower resistance motor, and I don't know how to tune the steppers on this particular 3D printer, so what I did is I put the original motor on. So right now the original motor is on, so it has probably more torque, and the extruder is now working. As you can see, there's filament here, and so the next step is we need to calibrate the E-steps. The 415 was only the default. So basically what I'm going to do is I'm going to make a mark here right at the edge. There we go. So the filament is right at the edge of this piece of Bowden here. And then I'm going to command this thing to extrude 10 millimeters. Then I'm going to measure with my Exactomatic eyeballometer here. I'm going to measure how much came out, and then we'll apply a formula to calculate the amount of E-steps we need to do in consequence. Just your friendly neighborhood editor here. I guess the video went worse than I thought because I didn't record this part. So basically, what you do is you measure what came out, and you go to a website like this one here, linked in the description. You put the amount of E-steps that you set your printer to. You extrude 100 mils, like I was saying, and then you put the measurement, how many you've extruded, and it gives you the new E-step value. So you just set that into pronter face or whatever you want, and then you extrude another 100 mils and you do the measurement again, and you should be pretty darn close to exactly 100 mils. If not, you have to do it a couple times until it works. Back to the video. 411 is now stored into the system. I'm just going to make a new mark right at the very edge, and we're going to run it again this time. Hopefully we're going to get exactly 100 mils. Done extruding. Same deal now. We're going to hope we get exactly 100 mils. That's right at the line. We're getting 97.2. It's not quite right. Getting 97.5. So I'm going to run this a couple times until I get it exact. 100.79. I think I'm pretty happy with that. I can adjust the rest in the extrusion percentage. So yeah, I ended up slowing down the extrusion rate in order to make sure I wasn't skipping any steps. This filament here is actually a used filament. It's been through an extruder before, so maybe the diameter is not quite accurate. I'm not sure what the deal is, but now this is done. Don't think you're off the hook so early. We also have to address one more problem with my 3D printer, is it does not have a parts cooler. It was bottom of the barrel, so you know, didn't expect too much. So Banggood has sent me this thing. This is a sort of an axial fan, radial fan, axial fan, I don't know. It's a blower. This does the spinema thing, and then it blows air out this way. This is very common for a parts cooler in 3D printers. It's relatively silent as well. I could have designed the perfect mount for this thing, but you know, time was of the essence, so I found one on Thingiverse for my particular printer, and it's designed to bolt up sort of like this, and it bolts onto the printer with this hole here. That doesn't work for me. First of all, I couldn't find the right bolts for this. It's a fairly deep design, so basically some of you are not going to appreciate this, but kind of too bad. I am going to hot glue this into place at such an angle that I can reach the bolt here. So yeah, it just is what it is, folks. A little bit of glue there, and make sure that gets tacky, and then I'm going to put a little bit of glue on the other end, and that will be plenty to hold it in place. I am not concerned about this in the least. And also I have to extend the wire, because the wire on this thing is very short. There we go. I can even give it a little hit of glue on the back side here. That is not going anywhere. So that is plenty solid for what we need. Next thing is to cut this wire, and I actually have some extensions made up. I went a little bit nuts because I typically go too conservative with my stuff, and I end up with just slightly less length than I want. So here it goes. I'm going to cut about here, and now I got to separate these two. Whoops, you didn't see that at all. I'm going to separate these two like so. I'm going to strip the ends off. What gauge is this? I don't know. Small gauge. 24 maybe? Yeah, these are tiny, tiny wires. I'll split these apart a little bit. Same thing on the other side. Take these guys and split them apart. These are the strippers kindly sent to me by another maker. And then I can bring these in, put a touch of solder on both sides, and then touch them together and solder them together, but not before I put on some heat shrink. I've often forgot to put heat shrink on, and I won't soon stop forgetting. Like that. Like that. And like that. This is just some cheap heat shrink tubing I had in stock, and now I also have this big 3-to-1 stuff, which I will cover the whole thing in with. I'll cover up the whole thing so I get more mechanical hold because it has adhesive inside. Just gonna bend these out so that the heat shrink doesn't fall off, and I'll bring you back when that's done. Figured I'd bring you in to show you. So this is the plug end, and there's my 2 solder joints, and here is my 3-to-1 heat shrink. I'll bring on top like that, and then we'll heat that up. I really like this stuff. I think I would like some smaller sizes, so I think I'm going to put in another order for them, because again, they're really cheap to buy overseas. They're very expensive to buy locally. So it's one of those things where when you need it, you probably don't have the couple of months to wait for it, so you might as well just get it in advance. Just gotta let that cool completely now. You can even slide it a little bit higher up because I missed the heat shrink by a little. There we go. Finally, at the last step, I have plugged in my fan. I saved you the trouble because you can't see anything anyways. So the fan is all plugged in, and here it is, ready to rock. All I have to do now is unbolt this one screw there, put this in like so, and make sure I do not twist this hot end section. If it twists, this sensor here is no longer going to be calibrated, and honestly, with how rough this has been, I don't want to recalibrate it. So here's hoping. Also note, it's probably not a good idea to do this over an open main board, which is just sitting underneath, and the whole thing is still on. And there we go, installed. I've already tested that it works. I just need now to manage the cables a little bit. It won't be a crazy cable management experience. And test print. And here it is. This is not only a benchy, it's a model designed to test your 3D printer's capabilities, but it is also the first benchy I have ever printed. And before I get going on the details, I just have to say, this is pretty impressive result. Don't forget, this 3D printer was cheap as chips. However, there are a few things we can glean from this. First and foremost, there is supposed to be text underneath here, and that text is barely visible, but mostly all melted together. That's because my nozzle is way too close to my bed. This is something I've been struggling with for a long time because the bed is actually warped on my 3D printer, but this is just to show you that you can still achieve good prints even with a non-ideal setup. Second thing you can see immediately is that there is a layer shift. If you look, the whole cabin, the whole upper part here is shifted that way. And what happens is these stepper motors are not intelligent. They don't know when they've gone somewhere and come back. They don't know if they've made it all the way to where they were sent. And so what's happened is these overhangs here, little part that curves like that, the filament must have cooled strangely and actually curled up, and then the nozzle came and whacked into that, sort of like that, kind of making a flicking effect. And so some steps were missed, and then it continued after that. I'm not sure really how to fix those kinds of problems. I think it's faster cooling, better part cooling, but yeah, that's an issue I'm going to have to resolve at some other time. On the positive side, though, one thing that is very difficult for a printer without good parts cooling is this smokestack here, the chimney. Because what happens is the layers take so little time to put down that it doesn't have time to cool before the next layer gets put on top. And usually it makes like a squidgy stacking effect. But this one here is actually really good. There are a couple of strings here and there. So there's one there. That's going to be really easy to clean up and remove. And the overhangs are not phenomenal, if you can see up there. But overall, this is a pretty good result for the price of the 3D printer. And so that's it for this video. If you want to see the other 3D printer upgrades that are going to happen on this 3D printer, I highly suggest you hit the subscribe button. And thanks for watching.